Okay, we are going to take a look at lesson 11 practice problems where we are identifying what a polygon is and doing a little bit more practice with some area. So in this question, it's asking us to select all the polygons. Well, if we remember from the lesson, polygons are composed of straight line segments and vertices. So this one is a little tricky because a lot of people think a polygon just means a closed shape, but we're looking for straight lines and vertices. So A is a polygon. C is a polygon, okay? And I'm not going to select D because this is open, and that doesn't work. And I'm looking at these two, and there's no straight lines. No straight lines. Okay, they're curved, so these two are not polygons. Now this one is a little tricky because it does have straight lines and it does have vertices, but this is a three-dimensional shape. This is a 3D shape, and a polygon is a two-dimensional shape. So if I go back to the review here, I can look at the summary and it says a polygon is a two-dimensional figure composed of straight line segments, okay, where there's a vertex and there's edges or sides, okay? So technically this does not qualify because it's not a 2D shape. So the only two polygons here are A and C. Okay, so there you go. All right, we're going to skip question number 2 and we're going to look at question number 3. Now, question number 3, we're going to find the area of the trapezoid, and we don't do a lot of work with trapezoids, but trapezoids are just like parallelograms. In fact, a trapezoid and a rectangle, you can actually almost make a rectangle or parallelogram by doing that little trick where we took this triangle off, and then if you kind of rotate it around and you put it on this side, you'll actually have a rectangle. See that? So a trapezoid can be easily found by connecting these line segments and making two triangles and finding the base and the height. So I'm going to just go through this one way that I would do this, me personally, because in my mind I can see that there's wings on the side of this shape that I can cut and make two triangles. So I have one here and I have one here. I've just decomposed this into three shapes. Two congruent triangles that have the same height and the same base, okay, and then this rectangle in the middle. So I know that my rectangle has a height of 3 and a base of 4. So this would be 3 times 4, and that's 12. And I'm going to circle it so I know that's the answer for this inside. Now I just have to do my rectangle or my triangles. Now remember, really, if you think about it, I can cut this one off and I can rotate it and it's going to fill this space right here. See that? So this right here is the same as this space right here. Okay, so I can either just do base times height and call it a day, or I can find the area of each of these separate triangles and add them together. So I'm going to show you both ways. So my height here is 3, my base is 2, but because it's a triangle, 3 times 2 is 6 divided by 2, which is 3. So this guy has an area of 3. And then watch, I'm going to do the same thing over here. 1, 2, 3. Height is 3. Base is 2. Again, 2 times 3, or 3 times 2, is 6. Divided by 2, because it's a triangle, is 3. So you can see that both of these triangles are congruent. They are the same. So I could have just done 3 times 2 and said 6 because 3 plus 3 is 6. This triangle rotated around, joining this triangle makes another rectangle. But together, they make a total of 6. This one plus this one. So 6 plus 12 is 18. So the area of this entire trapezoid is 18 units squared. Okay? Now, this is just one way that I could have calculated the area of this trapezoid. But I always find that if I can divide something into triangles, again, you can see that there's a triangle here, and there's a triangle here, and that makes that rectangle in the middle, which is easy to find. And now that we've had so much practice with finding the area of triangles, you could just find the area of these two triangles. Just remember, whenever you're finding the area of triangles, it's base times height divided by 2, because it's half a rectangle. All right, I'm going to skip question number 2. This one's a fun question, but we're going to take a look at questions 4 and 5. Question 4 is asking you to find the base and the height. Okay, so again, look at each side. Do you see how the line segment cuts the boxes? That's not going to be a good base. See how the line segment's cutting the boxes? That's not a good base. But look at this guy. See it? That's a beautiful base. And it's at the top, but that's okay because you can have a base at the top. It's just rotated. Okay, so we have a base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the base is 11 units. And the height is going to be directly across from the base. So if the base is at the top for this one, here is the bottom. Here's that. I'm going to draw that. See, now this time we're doing ceiling and floor. We went from ceiling to floor. And I'm just going to sketch the floor. See that? All right, so now we can see the height. I'm going from this part of the triangle, the flat top part, to the bottom, and here's that point. And you can go down here, you can go here, you can go here. You can do any of these 2 boxes because that's the distance between the base and the point across from the base. So my height is 2. Now watch, I can rotate this around and you can see how the base and the height are much easier to see, right? So there's the base, there's the height, but there's that imaginary ceiling. So you're going to have that same distance across the whole entire top and bottom of your shape. Okay, 2 times 11 is 22, but because it's a triangle, I'm dividing by 2, so it's base times height, or height times base. The order doesn't matter, but we have to divide by 2. Divide by 2. Because we want half, 11 square units. Okay, last question on this, and then you guys will be able to prepare for the mid-unit assessment, but you should be really good at this stuff by now. All right, so on the grid, we're going to draw 3 different triangles that have an area of 8 square units. So base times height divided by 2 has to equal 8. Base times height divided by 2. So something times something divided by 2. Now that gets a little tricky. So let's see if we can think of it this way. Instead of divide by 2, what if I multiplied by 2 and I thought what times what would give me 16? Because if I do something times something, that equals 16, then when I divide by 2, I'll get 8, right? So this might be an easier way to look at it. Let's kind of work it backwards. We're working it backwards. Instead of divide by 2, we're going to multiply by 2, okay? Remember, we're looking at the inverse. And the reason why we're doing that is because they're giving us the area. They're giving us the end result. We know we need 8. So if I do the opposite of divide by 2 and I multiply by 2, then I can think of 2 math facts that equal 16, and that will help me find some areas of squares. So right off the top of my head, I think of 4 times 4. 4 times 4 is equal to 16. It's telling me I need to make 3. Okay, so that's 1. I could do 8 times 2 or 2 times 8. That would equal 16. And then I could do something like 16 times 1, but that's going to make a really tall and kind of narrow triangle, but I certainly could do it. I mean, let's just go ahead and do 1 times 16. Now, all three of these will, if I divide by 2, will give me 8. See how I did that? All three of them will give me an area of 8. So now I just have to construct them. Base times height. Now, always start with the base. Now you can pick. I mean, the 4 by 4 is easy because that's the same. But you can pick. I'm going to start with the square one, 4 by 4. So I'm going to start in this top corner here, and I'm just going to go a height of 4 and a base of 4. See how I did that? That's it. So that's my first one. I have a base of 4. I have a height, and I'm just going to write h of 4. And then I'm just going to connect them right here. Okay, there we go. So 4 times 4 is 16, and 16 divided by 2 is 8. So that has an area of 8. All right, now let's do 2 times 8. Now, do we want the base to be 2, or do we want the base to be 8? I'm going to say let's make the base 8. I think 8 might be good for that. We'll make the base 8. So I'm just going to go across 1, 2, 3, 4, 5, 6, 7, 8. So my base is 8. We could have made it 2, but we're going to say the base is 8, and my height is 2. Now remember, the height is going to be 2 boxes away from the base. So this is my height up here, 2 boxes, and I'm just drawing that imaginary line. I know that this has to be my base. It can't be any more than 8 units, okay, because that's what my base is. But the height can be 2 units across. Well, I need to put a point somewhere on this line segment, and it can go anywhere. I can put the point here. I can put the point here. I can put the point here in the middle. Okay, let's put it right in the middle. I'm going to put the point right here in the middle of 8. So 4 over and 4 over. Now I can just connect the dots. And if you have a straight edge, it would work better, but if you don't, just freehand draw it. But I could have put the point over here, I could have put the point over there, and connected the dots, okay? So either way would work, and I'm just going to draw this a little bit straighter here so you can see it. See how nice it is to have a ruler handy. Okay. All right, so my base is 2, and I'm 8, and my height is 2. And 2 times 8 is 16, and 16 divided by 2 is 8. All right, the last one is really hard because we've got a base of 1 and a height of 16, or the other way around. I'm going to do a base of 1. And this is going to look like a really weird triangle, but that's okay. I'm going to put my base. Well, first off, let's count the boxes and see if we have 16 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can't do a height of 16 this way, but I could rotate my paper around because see, I have more boxes. Do I have 16 boxes from here to here? Let's see. If I put my base right there, if I make that my base, which is 1, the base is 1. Let's see what my height could be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh my goodness, guys. So this one gets a little tricky because our triangles are going to overlap a little bit, but that's okay because 1 times 16 is 16, and 16 divided by 2 is 8. So I'm going to make my point. Let's see. I'm going to slide my base over because if 16 is the whole width of this, let's make my base here instead of here. And let's make the point of the triangle here. I don't know. This is going to be really hard. I'm going to definitely need my straight edge. Okay. So look at this, guys. It's like this really tall and thin triangle. Whew, that is a very crazy triangle. So I have a base of 1 and a height of 16 going from this end of the graph paper to this end. And that would be my height, which is 16. Okay, wow, that one is really tricky. Hopefully you won't have to make one like that on the test, but these two are pretty easy to make. Okay, those two were pretty easy to make.